So it starts like this. Okay, we have seen that how to integrate sine x. Okay, we know that its integral is minus cos x plus c. Okay, we know that integral of cos x, that is sine x. Okay, and we know that the integral of secant square dx, that is tan x plus c. Okay, now your syllabus is limited up to these three techniques of integration. Now, if you get something trigonometrical, but that is none of these three, so you will not try to integrate that directly. You will have to use the trigonometrical identities, and you will try to bring sine, cos, or secant square into that so that you can integrate that directly. Now, for example, a very typical question can be, you can be asked to integrate tan x. Now, if you look at your list, which is really a very short list here, so we can't integrate this tan x, okay? So what you will be doing is, you will change that tan x into sine x over cos x, okay? Now, using that ln thing, that this is a rational function now, you have cos x in the denominator, and its derivative is minus sine x. So you will write a minus here and a minus here. So now we can write that this is going to be minus ln cos x and then plus c. Now, similarly, suppose you have been asked to integrate tan square x. Okay. Again, we can't say this is tan cube over 3. No, not at all. So you have to use that identity that 1 plus tan square x, that is your secant square x. So this way, I can write it as secant square x minus 1 dx. Okay. So now we can integrate this. I can write this as, this is going to be tan x minus x and then plus c. Okay. So now suppose you have to integrate. Now there is a question which says 1 plus cos raised to power 4x over cos square x. Okay. So there are no such rules. We can only have the sine x, cos x, and the secant square x. Okay. If you split this, you get 1 over cos square becomes secant square x, and then cos to the power 4x over cos square x, that is going to be plus cos square x. Okay, I believe the rest of the class, they are doing their work. They are not looking at this video, okay? So you know how to integrate the secant square x, but this cos square x, that is a problem now. And this is a very, very frequently coming question in your past papers. You will see many, many questions where you will have to integrate the cos square x, or you will have to integrate the sine square x. Now, please remember that you can never say that this is going to be cos cube over 3 or this is going to be sine cube over 3. No, not at all. Remember, there is no power rule. There is nothing. We have very limited resources for this integration. So you can have either the sine x, the cos x, or this secant square x. Okay. Now, how to integrate this cos square x and then this sine square x? Okay. I'll be going to the next slide. Okay. Now, when you have to integrate this, the question is we have to integrate this cos square x. Okay. So then you must recall the identities that you have already done, that is your cos 2x, which is cos square x and minus sine square x. And then you remember it's two other forms, that if you change this cos square x with 1 minus sine square x, so this is going to be 1 minus 2 sine square x. And then you can say that this 2 sine square x is going to be 1 minus cos 2x. Or you can say that this sine square x is going to be half into 1 minus cos 2x. Similarly, there is another form of this cos 2x, like if I just write this again, now this cos 2x is going to be, if I change this sine square x this time with the 1 minus cos square x, so you have this as 2 cos square x minus 1. So this is going to be 2 cos square x minus is equal to 1 plus cos 2x. And then this cos square x is going to be 1 over 2 into 1 plus cos 2x. Okay. If you look at this very closely, we'll see that there is just a difference of the sign. It is a minus here, and the other one, this is a plus here. Okay. So if there is a plus here, this is going to be cos square x. If there is a minus over here, then this is going to be sine square x. Okay. Now, why are we doing this? If you look at this sine square x, that is equal to this form. If you look at this form, there is no power on this cos. If you look at this form here, there is no power on this cos. Okay, so that is the prime objective of writing using this identity. So when I have to integrate this cos square x, I'll write it as half into 1 plus cos 2x, and I can integrate this very, very easily. So this will be half into this is going to be x plus sine 2x over 2, and then plus c. And if you quickly look at this, that how to integrate that sine square x. Okay, so for the sine square x, we can write this as half into 1 minus cos 2x, and this gives you half into x minus sine 2x plus c. So that is how you integrate the sine square x and cos square x. Now there's one very important thing here. Now suppose you are asked to integrate, let's say you have to integrate um, that cos square 2x maybe. Okay, so if you remember that if your cos square x is half into 1 plus cos 2x. Now look at the ratio of the angles over here. Like if this is x over here, this angle is 2x. So if you have cos square 2x, so this should be half into 1 plus cos 4x. So you will change this with half into 1 plus cos 4x, and then you will integrate it. Okay, this is going to be half into x plus sine 4x over 4 plus c. And one last thing, sometimes you have to integrate something like this. Suppose you have 6 sine x cos x. Again, there is no product rule that can help us integrate the products like this. So you have to recall the sine 2x formula. The sine 2x formula says that sine 2x is 2 sine x cos x. So you can change this with 3 sine 2x. And here you have its integral, that is minus 3 over 2 cos 2x plus c. Okay, so that is how you do this. So thank you very much.